Welcome to our today's session, grade 9 mathematics. This is what we had for midterm exams. So I want us to take time and revise this paper. Welcome to our session. Make sure you comment and also you give your feedback, and also you can also like and subscribe. Our session begins right away. So this is the whole of that paper, and there is one page that is missing. I intend to put it in another video, so make sure to check it after we are done with this video. So we'll go very fast over this paper, then we also have some time in other video checking the other part of this paper. So we have section 1. We have the first part, and the question here is use number line to work out the following. We use a number line to work out what we have here. So that the number line is here. The number line, what you have in the number line is here. So I'll go to my working space, and we have, the question is, we want to use a number line to be able to solve that. So let me rule my space like that. We have that, so a space. Then we have that. So we have plus 5 into bracket minus again into 4 into bracket, then minus 5 again into bracket. So I want to use a number line here. Use number line. So in using number line, this number is the same as plus 5 minus plus 5 minus 4 minus 5, because here it's a positive and a negative, gives you negative. Here is a positive and negative, gives you a negative. So if I use my number line, this is question number 1. I use my number line. My number line looks like that. So I'll begin with the first number, which is plus 5. So I put plus 5 here, plus 5. Then on my right of this one, because it's supposed to move like that, most likely I have 6 here. Then here I have plus 4. So my number line is like that. So I start using that to solve this one. So if it is minus 4, it means I'll move from where plus 5 is, somewhere here. I move backward 4 steps. So we have 1, 2, 3, 4. So that is up to this one. Then minus 5, minus, still I move towards my left 5 steps. So we have 1, 2, 3, 4, 5. Then this one is plus 3, this one is plus 2, this one is plus 1. Then you have 0, you have minus 1, you have minus 2, you have minus 3, then you have minus 4. So the answer is found here. It is an arrow, so my answer is minus 4. So that is the answer for that. Number 1. Number 2, we have question number 2. Question number 2 reads, evaluate whatever you've been given here, 3 marks. I come back to my working space. I want to evaluate 10 minus into bracket minus 72. Then you are dividing by 3. Then here you have 3 is into bracket, then you have 8, then you multiply by minus 7, like that. Then denominator is 11, you multiply by minus 2, like that. So if I want to evaluate this one, I'll first of all begin with the numerator, and the numerator reads 10. We have 10 minus 72. Then you are dividing by 3. Then here you have 8. And this question, some corrections were done so that this one was supposed to be like this. Even here you're having like that. Then you multiply by minus 7. So I'll follow BODMAS. I ask myself, do we have brackets? Yes, we have. So I first of all try to do away with the brackets. 10 negative is supposed to give you positive, so plus 72. Then we are dividing. This is 3. Then you're multiplying by 8. Then multiply by minus 7. So I'll first of all begin with do we have off? We do not have. We go where we have division. Division is that one. I take 72, I divide by 3. So 72, we are dividing by 3. By 3, 1, by 3, 2, then you have 4. So the answer here is 24. So my new sum, numerator is 10 plus 24. Then you are multiplying by 8. Then you multiply by minus 7. Do you have another division? No. The next one is multiplication. So multiplication, I can either take this one, I work it out, then I multiply my answer by 24, so that I will have 8 multiplied by minus 7. The answer will be a negative, because if you take a positive number multiplied by a negative number, it's supposed to be a negative number. So I'll come and take 8 multiplied by 7, so 10 plus 24. You're multiplying by, this one becomes a minus, then 8 by 7, this one gives you 56. So I work out this one, so I multiply this one again, so you're having 56. I multiply by 24, I get my answer 6 by 4. This one gives you 24. I carry 2. Then this one gives you 22. Then 2 multiplied by 6, 12. I carry here 1. This by this, 10 plus 1 is equals to 11. So we have 4, we have 4, we have 3, we have 1. So it is 10. We are adding, this is negative, supposed to be negative because it's a negative positive, supposed to be negative 13, 4, 4. So now I work out this one. This is a positive. 10 minus 1344. My answer will be 1334. Then when I come to denominator reads 11, you're multiplying by minus 2 into bracket. So negative, this is the same as 11, you're multiplying by minus 2. And if I take 11, I multiply by minus 2, positive, negative is supposed to be negative. Then 11 multiplied by 2 is equals to 22. Therefore, numerator all over denominator is 1334. I am dividing by 22, a negative. And this one is the way it is here. I can try and simplify. I ask myself whether there is a number that can divide the two of them. Of course, by 2, 11. By 2, This one is 6 because of 12, remainder 1. 13, that one is 6. Remainder 1, that is 14, 7. So we have that. I ask myself whether 11 can go into 667, and I see 667. I divide by 11. It goes here 6 because of 66, 0. Then I drop here 7. It's not possible, so 60. Then the remainder here, it is 7. So my answer, remember this one is a positive, you divide by negative, it is a negative. Then I take 60, remainder 7, all over 11. So that is when the numerator is like this. But in other cases, if the numerator was, I try to solve the way it was initially before, 10 minus 72, then I am dividing by 3, then here we had 8, then I multiply by minus 7, like this. So this one is all like that. I'll first of all begin by solving out this one. If I open this, the division here together with that, I will have 10 minus this minus, and if I take 72, this one is 24, so it's like 72. I am dividing by 24, which will give me 3. So this will be negative 3. Then I am multiplying by minus 7. So you can see this is the same as 10. Negative will become a positive. So minus, this is 21. So that my new sum will be 10 minus 21 will give me minus 11. So if my numerator becomes something like that, then denominator will remain the same. Denominator is just the same thing. So it's now numerator all over denominator. Numerator is minus 11. Denominator is minus 22. If I take a negative number divided by a negative number, will give me positive. So this will cancel each other. So by 11, 1, by 11, 2. So the answer can as well be 2, like that. So if otherwise, if correction was not done, this is what I was supposed to get for that. Number 3, question number 3 reads, you round off this number to the nearest 10 million. So I want to round off. I'll come here and do the rounding off. We want to round off, and the number is 3. We have 274. Then we have 5. We have 318. So to the nearest 10 million. To the nearest 10 million. So I'll come here and get the place value. Which number lies in the place value of 10 million? So this is ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions, tens of millions. So this is the number that I'm checking. But before I round off, I check the number before, whether it has reached 5. If it has reached 5, I add here 1. But if it is less than 5, I just leave it like that. So 7 here is more than 5 actually. So I'll add here 1, so that my answer will be 3, 3, this one. Then the rest of the numbers, I turn them to be zeros. So I'll have how many zeros? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you have that one, the nearest 10 million. The next number is number 4, which the question reads, what is the least number that should be subtracted from this number to make it divisible by 11? What is the least number that should be subtracted from this to make it divisible by 11? Now, divisibility test for 11. So if I come here and have, I want the number that can be subtracted from 3, 4, 8. Then you have 5, 6, 7. I want the number that can be subtracted from this to make it divisible by 11. Now, divisibility test for 11, I am supposed to check like this. I check the difference of the sum of the alternating numbers. So the alternate of 3 is 8. The alternate of 8 here is 6. So if I take 3 plus 8 plus 6, this will be 11 plus 6. That one gives me 17. Then 4 plus 4 plus 5 plus 7. This is 9 plus 7. So it gives me 16. So I want a number, the difference of the sum. So this number, of course, is not divisible by 11 because if it was divisible, the difference of these two numbers, the difference, if I subtract here 1, is not 0 and not a multiple of 11. Therefore, let me say that I'll subtract a value like x. So I come the least number, so 7, I subtract the least number. I want the number that I subtract from this one. So 16, I subtract x, so that I want my answer to be 0. So that if it is 0, it will be a multiple or a number divisible by 11. So my number is 17 minus 16, then negative becomes positive x is equals to 0. So this is the same as 1 plus x is equals to 0. Therefore, x is equals to negative 1. So this is the number that should be subtracted from this to make it a divisible by 11. So let the number be x, so that I have subtracted from it to make the final answer to be 0. And now it is divisible by 11. The next number is number 5. Number 5. Let me open a new page. Number 5. Number 5 reads, use mathematical tables to evaluate the following. So you want to use tables to evaluate what we have here. So go back to my working. You want to use tables to evaluate that. Let me open my mathematical table to see whether we can use that. So we want to use mathematical tables to evaluate. A is 0.002. I want to use tables to work out that one. So the instruction here for number 5 is to use tables. I want to use tables, of course, the 4 figure. So let me check my table. We try and search the mathematical table to see what I can get. Mathematical table, the 4 figure mathematical table is this one. Let me open it. The mathematical table. Right. So this is the question here. Is I want to get, this is the square. So I'll go to the table of squares. So the table of squares is here. The table of squares is here. It is on page table of squares, the page 19. So I'll go up to where I have page 19. page 19 to see whether I can get that page 19. And that is page 9, page 17. I go to up to page 19. Good. So this is the table of squares. So we want to get the square of 0 point. So the table of square begins from this. This is the least number because the table below is simple equals. So I got the table of squares, this one, and it goes up to 9.9. The next table is the table of square roots. So in the table of squares, it begins from this value. And if I look at the sum that I have here, this number is too small. So I have to make it fit on my table. So I have to move this decimal. How many steps? 1, 2, 3. So I'll have to write 2.5 multiplied by 10. I have moved 1, 2, 3 towards my right. So it's a negative 3. So this one, the square here, I get the square of this one and I get the square of that. This one is 10, right? Now this, I'll get it from the table. So this, the answer for this one, I'll get it from the table. But this one, I can work it out from the power of indices. So this one, I can work it using my head, power by power. Negative 3 multiply by 2 will give you negative 6. Then 2.5 from the table, I go to where you have 2.5. 2.5 is somewhere here. There is no any other number, so I'll pick the one that is 0 here. So 2.5 is 6.250. So I'll come here and write from the table, this is the same as 6.250. To complete my working, I'll move back steps, this decimal, 6 steps. So I write 6.250. I move backward 1, 2, 3, 4, 5, 6. Decimal is somewhere here. So I write 0.00000. So you have how many zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 2, 5. So my answer will be like that. The next one is in our question, we have this one, and this is supposed to be cube root of this number. So I'll come and get from the table. I want, this was A, the B was 27, 1, 2, 3. I have the cube root of this. The same thing, I come now to the table of cube roots. The table of cube root, this is the table of square. Here you have square roots. The next table is the table of square roots cubes. And you can see we do not have a table of cube roots. So I'm going to use this table of cubes to get my answer. So I'll try to identify the number that I'm asked there, whether can be found here, because I want to go the reverse way. So whether the number lies somewhere here. You see the largest number here is 997. So it means that even our question cannot fit there. Therefore, I will have to write this one so that it can fit. This is the same as 27, 1, 2, 3, all this raised to power. Cube root is the same as power a third from the law of indices. So I move my power in a way that the number of steps I am moving, it will be divisible by 3. So that I don't complicate the number that will lie here. I want it to be divisible by 3 because I'll have to divide by 3 or even multiplying by a third. Therefore, I moved in such a way that it will be divisible by 3. So if I move one step, the number is still too big. If I move 2 steps, 270, it can fit. but I've moved 2 steps. He cannot be able to solve that. So I need to move 3 steps. So I'll have 27. I multiply by 10. I have moved 3 steps towards my left, so it's a positive. So this one, I get the cube root by multiplying by raised to power third. And this one, I'll get it from the table, the cube root of this one. Or I can write it like this, the cube root of that. So again, this one, the same way I got this one from the table, I'll come here and get from the table. So let me see 27, whether I can be able to read it from the table. So let me look for 27 around here. 27, it must be 27 exactly. It is somewhere here. So the number that is here, 27, this is what I want. 27 is here. 27, I pick, it is lies in 3.0. The number here is 0. So I'll come and write this way. The cube root of this one is 3.0. Then I multiply. This one now I take 3 multiplied by a third, by 3, 1, by 3, 1. So you see, if I moved a number that is not, number of steps that is not divisible by 3, it could have complicated my work here. So this one needs to be divisible by 3 as much as I want to make this one fit in my table. So by 3, 1 by 3, 1, so this is the same as 10 power 1, which is just the same as 1 like that. That if I take 3.0 multiplied by 10, my answer will be 30. So that is the cube root of this number. The next one is C, which is we try to get the cube. This is the cube because it's raised to power 3 of this number. So I come and do the same thing. The cube of we have 0. The question here, if I confirm 0.00, we have 1604, so raised to power 3. The same thing, this number is too small, it can't fit in my table. The table of cubes begins from 1.1, so I'll have to move the number of steps that to make it fit in my table. I can move 1, 2, 3. The decimal should be there, so I'll come and say 1.604. I multiply by 10. I have moved how many steps? 1, 2, 3. So I write 3. And because it was to my right, I write a negative here. So this power, I'll bring it here, 3. Then this one, I can read it from the table. So 1.60, 1.60, 1.60, 1.60. Then the next number is 4, 1.604. So I come from the table 1.60, then you're having 4 in the last column. So 1.60 in this column, then 4. 4 here, if I follow the straight line, 4 is 24. So I will say 4.096, 4.096, 4.096. Then the instruction here is to come and add. I'm supposed to add. So I'll come and add 24. So that this one will be 10, carry 1, 10, 12, carry 1, you have 1, have like that. Then here, this one I just multiply, negative 3 multiplied by 3, it will be 10, this 10, power negative 9. So my answer 9, 1, 2, 0, you multiply by 10 power negative 9. you have it there. Right, so we have power 9. So we have power 9 here. So this is a negative, so it means I am dividing by a number with 9 zeros. So it means I'm moving towards my left 9 steps. So I'll come and say 4.120. We move 1, 2, 3, 4, 5, 6, 7, 8, 9. So decimal is somewhere here. So these are how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So I'll come and say 0 0.1, 2, 3, 4, 5, 6, 7, 8, then 4, 1, 2. And you get your answer like that, right? The next question is I need to express the following in index form. Index form is in power form. So here you have this sum in index form. The other name for index form, index form, is also power form. So you have this number. Have the number here is you're having y multiplied by x, y you multiply by actually y multiplied by y, you multiply by y, you multiply by m, multiply by m, you multiply by m. Sorry, this is m, m here. So I'll just come and ask myself, this is y. Y appears how many times? 1, 2, 3. So write 3. Then I write m. M appears how many times? 1, 2, 3. So like that. So I can leave my answer that way, or I can go ahead and say, because they have the same power, I can say y, m, all this is raised to power 3. That is A. B is what you have here. 4 all over 5. You multiply by 4 all over 5. You multiply by 4 all over 5. You multiply by 4 all over 5. The next one. So that you're having 4 all over 5. It appears how many times? 1, 2, 3, 4, 5. 1, 2, 3, 4. One more time for 5. So this is just the whole of that one appears 5 times. These brackets are important because if you don't put them, it means that 4 is the one that only appears 5 times, and that is not the case. All of it. You can simplify by saying 4 raised to power 5 and also 5 raised to power 5. But this is the best way to leave your answer. Number 6, you have, you solve what we have here. You want to solve this sum. Solve the unknown, 9 raised to power 2x multiplied by 3 raised to power x equals to 27. So I'll come here and say we have end of that sum like that. So we have 9 raised to power 2x. I multiply by 3 raised to power x is equals to 27. Anytime I see indices of this form, an equation involving indices, I try to make the base the same. So 9 can be written to base 3. So it's the same as 3 power 2, all this 2x multiplied by 3. We are having x is equals to, this one is the same as 3 raised to power 3. Now that they have the same base, I apply the law of indices. And this multiplication, I can go ahead and open this bracket and see 2 multiplied by 2x gives you 4x. Then multiply by 3 raised to power x like that. Now, if this one, they have the same base, then multiplication of indices applies here. If you multiply two numbers with the same base, you can add their powers. So this is the same as 3. 4x plus x gives me 5x equals to 3 raised to power, was it power x? This is not here. So let me rub here. This is not here. Supposed to be 3. So that this is supposed to be 3. This is supposed to be 3. Therefore, if now the base are the same here, I can now equate their powers. So 5x is equals to 3. Then divide by 5. I divide by 5. By 5, 1. By 5, 1. So the value of x is equal to 3 all over 5. And that is the answer for x. Right. If we go to the next one, the next question is a simultaneous equation. Allow me now to solve these two. I will create a lesson specifically solving the simultaneous equation separately. So I will solve this two in a different session because I want to have a lesson specifically simultaneous and the different methods of solving this. So make sure you keep on checking because I'll also present this one. It's important because of many students normally ask of different methods of doing that. So let us go to number 13. And number 13 here, we have a shape here. So they want us to get the area of the shaded part. Area of the shaded part. So if I come to the working here, I hope this will be enough. The diagram is like that. We have like that. And this is a form of a sector. So I have like that, and I have that. So they want me to get the area and the pi. This is number 13. You've been given the pi is 3.142. So, and the angle here is 73 degrees. The distance on the other part, we've been told it is 12 and 5. 12 and 5. So that we have 12 and 5. We go to this one. The distance here from this one is 5, and this one is not 5. This one is 12. 12. This is 12, and this one is 5. The distance here from here up to here and up to that particular point, and this one like that and like that. So if they want me to get the shaded area, it means I'll get the area of this sector minus this area. So how do you get area of a sector? Area of a sector is given by theta all over 360 pi r squared. This theta is the angle here. Then pi we know, and the radius is the distance from the center to the circumference. So I'll get the area of the whole of this one, you minus this one. So the big sector, the area will be, so if I get shaded area will be the area of the big one. So I'll come and say area of the big one. This is the formula for getting area. The angle is 73 all over 360 multiplied by 3.142. That is the pi. Then the radius. The big one, the radius is distance from here up to here, or from here up to here. So 12 plus 5, that gives me 17. So I get my answer here. I can use a calc to see what is the answer. The other area, so this is the first one. The other area, I get the area of the small one. The angle there, still I'll use the same formula. So the angle is 73 all over 360. I multiply by 3.142. Then I multiply by the radius. Remember this one is squared. The radius will be 12. So it is 12 squared, 12 squared. So if you work this one out using a calculator, let us take 73 all over 360. I multiply by 3.142, then I multiply by 17 squared. My answer will be, the answer here will be 184.13 to two decimal places. So this will be centimeters squared. This one, again, I'll come and say 73. I divide by 360. I multiply by 3.142. I multiply by 12 squared. The answer is, to two decimal places, it will be 91.7464 centimeters squared. So if I want to get the shaded now, it will be this area minus this area. This is the area of the bigger one, the whole of this sector, minus area of the smaller one, meaning this small sector here. So if I take this answer minus, I want to take this answer, be careful here, I minus this answer. So it will be 184.13. I am subtracting 91.7464. If I subtract that one, the answer will be 92.3836 centimeters squared. So this is my answer. Hope it is clear there. It is 92.3836. So we have that. Right. The next one is the next sum. It's what we have here. Can read it together. A company wants to make a cuboid box, each measuring these measurements using a wooden box. Determine the surface area. So I'll go the other side and I try to draw a cuboid. How does a cuboid looks like? So let me divide my section in that form, and we have that one. So a company wants to make a cuboid box, each measuring that one. Cuboid is of this shape. We have a cuboid like that. I extend like that, extend like that. It's like a box, a cuboid. So I have like that. Then if the side that I cannot be able to see, I put it dotted, then you're having that. So it measures 60 by 40 by 30. This one is centimeters, centimeters. Then here you have your centimeters, like that. Now, if they want me to get the surface area, this is number 13. So the surface area, I'll get the areas of the faces. So I'll get this face, which measures 60. You multiply by this side, measures 30. Then my answer, I multiply by 2. So this is this face together with this face, the other face on the other side. If I come to this side, I hope you can see, it measures 40 by 30. So I'll come and say 40, I multiply by 30, and we have two faces, this side and the other side that you have there. So that there are 2, I get my answer. Then I come the upper part and the bottom part. The upper part measures 60 because the same as this distance, 60 by 40. So I'll say 60, I multiply by 40. Then the up part is same as the bottom, so I multiply by 2. So that I get these answers and I add all of them together. So 60 multiplied by 30, 6 by 3, it is 1800. Then I multiply by 2. This is the same as 4 by 3, it is 12. Then two zeros, then I multiply by 2. Then this one is the same as 6 by 4 is 24, 0. Then I multiply by 2. So that total will be, I'll take the sum of these. So 18 by 2 gives me 36, then two zeros, plus this one by this, it is 24, then two zeros, these two zeros, then 24 by 2 is 48, then two zeros. If we try to add this, we see what the answer will get. Actually, that these are 36 plus 24, that gives you 50. So 50 then plus 48, that gives us 98. Then two zeros, this one is centimeter squared. You can confirm that. The second part, you calculate the volume of the wooden in cubic meters. So volume is length multiplied by width multiplied by height. So it is length of 60, you multiply by width of 40, you multiply by 30. The answer here will be 60, you multiply by 40, you multiply by 30. My answer gives me 7,000, 72,000. 72,000, but this is centimeters cube. Now, if I want to convert into meters cube, I know that 1 meter is equals to 100 centimeters. So if I put cubic, it means I'll multiply 100 by itself 3 times because it is a cube. So I'll come and say 100 by 100 by 100. It will mean that is a million. 1, 2, 3, 4, 5, 6. So this is centimeters cube. So if I want to divide this one, convert 72,000 centimeters cube into meters cube, I'll have to divide by 1 million. So I'll have 72,000. I'm dividing by a million. 1, 2, 3, 4, 5, 6. The 3 zeros will go with the 3 zeros. So 72 divided by 1,000 is the same as 0.072. This is meters cube. So we have our answer is like that. If I go to number 14, number 14 reads, number 14 had a concern. The cash price of a car, number 14 especially B, the cash price of a car was shillings 87,875,000. Mola bought it on hire purchase terms. The hire purchase price was 100,000 shillings more than the cash price. You calculate the hire purchase price. All right. So I'll come to number 14 here. Number 14, and I check what I have here. The cash price of a car was, so the cash price, let me write the cash price is shillings 875,000. Mola bought it on hire purchase terms. The hire purchase price was 100 shillings more. So hire purchase was 100,000 shillings more. It was 100,000 shillings more than the hire purchase. So if I want to get, if the hire purchase was more by 100, it means I'll come and add here. So hire purchase, this is question A. The hire purchase will be 875,123, then 100,000. Let me write 1, 2, 1, 2, 3. So we add so that it can be more. So this 0, 0, 0, 5, we have 7, we have 9. This is the hire purchase because it should be 100,000 more than the cash price. Right. B of that is that you calculate the deposit if you paid equal monthly installments of Kenya shillings. So monthly installments is supposed to be shillings 200,000. 200,000. Now, although we want to get the deposit, now we don't know how long because the hire purchase price is equals to the deposit you plus total installments. So we don't know this 200,000 he paid for how long. So that if I know total installments, because you're told that monthly he paid 200,000. So I need to know first of all what was the how long was he able to pay. So I'll fix a value here. If it was if the monthly installment was for if monthly installments was for a period of maybe value like 3 months. 3 months. Let me say 3 months. 3 months. So each month he takes this month, this as installments, 200,000. So I'll come and say that hire purchase is equals to the deposit, which I don't know, plus each month he takes 200,000 for how many months? 3 months, if the period is 3 months. So let us see what is this deposit plus 200,000 multiplied by 3 to give me 600,000. We have that. So that the hire purchase is equals that. But I have the hire purchase here, which is 975,000, like that. So if I want to get the deposit, I'll take this one to the other side. And if it was positive, it will come subtraction. So that means that my deposit will be 975 zeros. You subtract 600,000. 1, 2, 3, 600,000. So if I subtract, will be 0, 0, 0, 5, 7. Then you're having 3. So this is the deposit. So that you have shillings 375,123 as the deposit. So that was in case we had the period of 3 months. I said that one there was a concern, but if the question was like that, then we will be able to solve it that way. Lastly, we have the last one, number 15. Number 15. Let me first of all have this one, number 15. I have number 15. And you have the two diagrams here. 15. I want to find the perimeter of the figures below. Right, perimeter here. I have the diagram here. If I draw the diagram like that, we have like that. We have like that. We have like that. We have that one. And we have that. So these are 90 degrees. 90 degrees. You have 90, you have 90, you have 90, you have again 90 here. This is 18. You've been told this one is 5. All of them in centimeters. 7. This one is 10. So centimeters. We have centimeters. We have in centimeters and all that. So perimeter is the distance around a figure. So I'll come and first of all ask myself, what is the distance here? Remember, from here, this one up to here is 7, and from here up to here is 18. So meaning the remaining part here is 8. Then the distance from here up to here is 5, and from here up to here is 10. So it means that the whole of this one is 15. Therefore, perimeter is a distance around a figure. So I'll take 8, this one, I add 15, this one, then I add 18, this one, I add 10, we have that, then I add, this one is 18, let me write well, this one is 18, so you have, this one is 18, then 7, we have 7, then you have plus 5. So if I add all this, if I take 8, I'm adding 15, I'm adding 18, I'm adding 10, I'm adding 7, and I'm adding 5. My answer will be, if I've calculated the right way, it's supposed to be 153 centimeters. So that is the LCM. This is question 15, number A. And number B, you have a diagram here that is of this form. I want again to get the LCM. So the LCM of this, the LCM of that. So it's supposed to be curved. We draw something curved like that, and you have something like that. All right, the mine is not perfect, but I want to get the LCM. Let me try and write well so that you have a clear diagram. I have that. So this one on the two sides from the question, this one is 42 centimeters and this one is 42 centimeters. That is the distance, that is the distance, that is the distance. Then here you've been told it's 70 centimeter. So again, perimeter is the distance around a figure. So from here up to here, 72. This is also 70, 70, and also this one 70. So sorry, this one is 72 centimeter, 70 centimeter, 70 centimeter. So perimeter is the distance. I'll begin from this point. Let me first of all get this one for a semicircle. And for a semicircle, perimeter is a half pi d. And because there are two of them, the distance of this one and this, I can multiply my answer by 2. So that I'll get this distance of a semicircle and distance of a semicircle. I'll come and say 2, you multiply by 1 all over 2, you multiply by 22 all over 7. The diameter here is 42. So by 2, 1, by 2, 1, by 7, 1, by 7, 6. So if I take 22 multiplied by 6, 6 by 2 is 12, carry 1, this one is 13 centimeters. So these are distance this side. So total perimeter, it will be, I'll take these two sides, which is 132 plus 70 and 70. So 70 plus 70. Then I say this one is 132 plus 140, and this one will give me 2 plus 0, that is 2, then 3 plus 4, that is 7, then 1 plus 1, that one gives me 2. This one gives in centimeters. So that is how we get the perimeter of these figures. I hope that was educative session, so you can go through it. If there is any concern, please let me know in the chat box, and also be ready also to receive the part of that we've left, especially solving simultaneous equations. We have a number of methods, so I would wish I put it separate so that you are able to learn it carefully. Thank you so much. Have a wonderful